Welcome to this lecture, that is data preprocessing in this machine learning using Python programming course. Since we have already seen there are many large data sets and these are of different types. So, when we are applying machine learning techniques on these data sets, so sometimes it is difficult to directly apply these machine learning techniques on the given data set in its original form. So, we will need to first convert that data set into a form, so that it can be suitable for a machine learning technique to work on that data set. So, we have different types of data sets like structured tables, images, audio files, videos and many other different types of data sets that we have seen in the previous lectures. And we know that directly your computer cannot read these data sets in the original form. We need to convert generally it into binary, so that computers can understand this data, and particularly machine learning algorithm can work on that data set. So, we transform the data set into different form. We encode the different features in the data set in different form, and then we apply machine learning techniques so that it can be easily applied over that data set. So, there are number of steps of data preprocessing, and in the real scenario it is not the case that each and every data preprocessing technique will be required, but we will study these different steps of data preprocessing in this lecture, and depending on the problem, depending on the context, one can choose which particular step is required in that case. So, these are different data preprocessing steps: data quality assessment, feature aggregation, feature discretization, feature sampling, dimensionality reduction and feature encoding as well as feature scaling. So, mostly these are considered as the data preprocessing steps, and we will see in detail what we mean by these steps. So, first of all, data quality assessment. So, the data set that we will have and we are trying to learn from this data set, first step is to check the quality of this data set. So, that is called as data quality assessment, and we have seen there are challenges with these data sets, like there may be missing values, there may be noises in the data set, there may be outliers. So, we need to check if there are some missing values, if there are outliers, if there are some inconsistent values in different features, if there are duplicate values in your data set. So, we will need to take care of all of these challenges if we are having these in our data set. So, this is the very first step in data preprocessing, that first of all we should check the quality of the data in terms of missing values, outliers, inconsistent values, duplicate values and so on, and then we will need to take care of these things, or we will need to handle these missing values, outliers, or if some inconsistency is there in the data or there are duplicate values. So, we can do, generally we do it using the software or sometimes manually, but we will need to do it as a first step in data preprocessing. The next data preprocessing step can be feature aggregation. So, sometimes the feature in our data set that is given in original cannot be used as it is, and there are chances that we may need to aggregate data in that particular feature. For example, if we want to see the transactional record of a particular product in different stores of a particular city, and we want to analyze it, then there are many options. Suppose your data set is consisting of day to day record, and in that case for each and every store there will be the sale of that product and it is recorded day by day. But we may be interested in aggregating this particular feature. For example, we can take the transactional record not day by day, but by month or by year. So, there are a lot of advantages in aggregating feature values, because it will compress your data set, it will take less memory in that case, it will take less computation power also, and definitely depending on the problem we will need to decide whether the feature aggregation is required or not. Sometimes if we want to, in this particular case, if we want to study on day to day transactional data set, in that case aggregation will not be a good step. But if it is not concerned with day to day transactional analysis, in that case it is always better to aggregate this. So, it will be easy in that case to, because it will take less memory and less processing time. And definitely since it will now then be a high level data of the original data set. So, it will be easy to analyze that data set also, because it is having the same detail, but in higher level way. The next step is feature discretization. So, sometimes we have features that are having continuous values, and it is easy or it may be helpful if we convert those continuous values into discrete values. For example, if we have age as a feature in our data set, so generally that age will be in terms of number of years or year and month and so on. So, there are chances that you do not need the exact number that is representing the age. So, in many of the cases you may require whether the age is representing the young age or middle age or old age, or there may be other way of discretizing this. So, generally it would be better to discretize age in 3, where it will have now 3 values: young age, middle age and old age. So, in this case also it will improve the efficiency, because you will not need to deal with all the continuous values in that particular feature in your data set. So, it is now discretized, there are only 3 values corresponding to that. But again it is you need to first of all check whether what is the requirement of the problem that you are having in your hand. Is it require a particular value, that is continuous value, or if you are discretizing it, it is working very well on that also. So, if there is no change, in that case it is always better to convert continuous values. Of course, this cannot be applied in each and every feature. For example, if it is a salary, so again we can convert, we can discretize this salary feature, because we can always say it is a low income or medium income or high income. But in other cases where we have some continuous values, there are less chances that we can discretize that. So, we will need to when we will deal with the data set, generally it will be very easy to understand whether there is a requirement or whether it is sensible to discretize that particular data feature in that data set or not. The next step is feature sampling. So, sampling is a very common method for selecting a subset of data set, or we have different feature sampling techniques. For example, simple random sampling as well as stratified sampling. So, in simple random sampling also we have sampling without replacement and sampling with replacement. So, generally if we have a large data set, so in that, and we are not comfortable to work on the whole data set, in that case we do the sampling, and then depending on the problem itself you will need to choose one of the sampling techniques, like if we are choosing simple random sampling, in that case also if you are interested in sampling without replacement or sampling with replacement. So, sampling without replacement, you will, when you are selecting some instances from the data set, then in one case you will keep those selected instances again in the data set after when you are selecting the next instance, and in other case you will not put this selected instance in the original data set when you are selecting the next instance. Then in case of simple random sampling, there are chances that we may get imbalanced data set. So, first of all we will understand what is imbalanced data set. So, if we are having a data set of normal as well as diseased persons, so we can say the healthy as well as patient data set. So, in that case there are chances that you may have many instances that are corresponding to healthy persons, but very few instances that are corresponding to patients. So, this type of data set where the number of classes that you are having, but each class is not, the group is not same in terms of number of instances, in that case it is called as the imbalanced data set. For example, here if the number of healthy persons are in large numbers, but your patients are less, in that case this is imbalanced data set. So, in the same way if we talk about multi-class classification problem, in that case also there may be one class for which number of instances are large, and for other class number of instances is less. So, in that case this data set is not imbalanced. So, we will see there are many techniques that we can use to handle with this type of imbalanced data set, but in that case if the original data set is large, then we can use stratified sampling to get a balanced data set. So, in stratified sampling it begins with predefined group of objects. So, suppose we are having 3 classes. So, we will start from the number of instances in all the 3 classes. So, in this way there are less chances that we will have the imbalanced data set. The next step of this data pre-processing can be dimensionality reduction. So, if your data set is having large number of features and you do not know whether all the features are important or not, then there are chances that you want to reduce the number of features, and this is called as a dimensionality reduction. So, there are different types of dimensionality reduction techniques. Few of them will directly select few important features that are relevant to the problem and will leave the rest of the features that are irrelevant to the problem. So, that is called as feature subset selection or feature selection. But in other cases, when we do not know whether the feature is important or not, whether which particular feature we should select or which we should leave, in that case there are other dimensionality reduction techniques, and in that case we get a new data set with a new set of features, and these new features are combination of previous features. So, any one feature in the new data set may be combination of few features in the original data set. The second feature of the new data set may be combination of few other features in the original data set, and finally the number of features in the new data set will be less than the number of features in the original data set. So, this is the task of dimensionality reduction techniques. They convert the original large data set into some small data set, small in terms of number of features. So, as we know, when we talk about data set, so number of features that you have, it is you can represent each feature with a one dimension, and so you can say that if there are 3 features in your data set, it is called as 3-dimensional data set. If there are 5 features in the in your data set, it is called as 5-dimensional data set. So, we represent this dimension as a plane when we represent our data set in geometric planes. So, each dimension represents a particular plane in the data set, and we can say as the number of planes in which you will represent your data set will increase, your data is that much complex. If you can represent your data set in less number of planes, then your data is more simple, because there are few planes that are required to represent your data set geometrically. It means there are few number of features in your data set, and that is why it is easy to understand or it is easy to work on that data set. So, when you are representing your data set geometrically and it requires a large number of planes, it means that this is high dimensional data set, and there are chances that you may need to use some dimensionality reduction techniques. That is one of the data pre-processing technique. So, you will use one of the data pre-processing dimensionality reduction techniques and reduce your data set into less dimension data set. So, we will see few dimensionality reduction techniques later. Two very important techniques are principal component analysis and singular value decomposition. As I already told you that there are 2 types of dimensionality reduction techniques. In one techniques, we directly select few features that are important to the problem and remove few other features that are irrelevant. But in case of principal component analysis, we convert data set into another form where the newly defined features are combination of features in the original data set. So, this is these techniques does not come under the feature selection techniques. These are other dimensionality reduction techniques. The next data pre-processing step is feature encoding. As I already told that it is not necessary that each and every step will be required in each case. So, it will depend on your data set, it will depend on the problem whether we require these steps to be applied as a data pre-processing or not. But there are chances that these steps may be required, and one of these steps is feature encoding. So, feature encoding is nothing but where we transform the given feature or existing feature into another form. So, it is also called as we encode the feature, and finally, if it is required, we can decode that feature also. So, this is called as feature encoding. So, here depending on the data type of the feature, there are different rules that we can use to encode that particular feature. For example, we have already seen that there may be features of 4 different types. So, it may be nominal feature, it may be ordinal, it may be interval, or it may be ratio. So, if your feature is nominal feature, in that case, if you want to encode that feature, you can choose any one-to-one mapping. Machine learning algorithm would work on the encoded feature. So, we will see one-hot encoding. So, this is one of the example of encoding, feature encoding, and we will see when we need this one-hot encoding technique. If your data set is having feature that is of ordinal type, so it means values in that feature can be, these are of course these are not continuous values, but these are some named values and can be ordered. So, then we say that this feature is ordinal feature, and in that case if we want to encode this ordinal feature, we will use some mapping so that this order should be preserved. For example, if we have a feature that is customer satisfaction, so in that particular feature customer satisfaction, we have unhappy, happy, very happy. So, if suppose these 3 values are there in customer satisfaction feature, and if we want to encode it, so we can map unhappy to 1, happy to 2, and very happy to 3. So, when we are saying 1, 2, 3, so we can find out the ordering that was there already in the original values in that feature. So, unhappy, happy, and very happy. So, these values were ordered in this way. So, that is why mapping is also done, so that when we see the encoded data, we can find out the actual ordering. If your feature is interval feature, so we have already seen that in case of interval feature, there is no 0 value. So, in that case, if we want to encode that feature, we use the formula like new value is equal to some constant multiplied by old value plus some another constant. So, in case of ratio feature, we do not include the constant that is added in the previous term. So, in that case we simply encode it with new value is equal to some constant into old value. So, in the next lecture we will see in detail how these encodings are done in case of interval and ratio, and we will see the remaining data pre-processing steps, and we will see all these in detail and maybe implementation of these steps also in the next lecture. So, I am stopping here. Thank you.